Hello everyone. In this video, we are going to discuss the high-level system design of Twitter. So this entire video will divide into 4 parts and will cover everything in 4 parts. The first part will discuss about the requirements. Generally, the requirements are of 2 types. The first one is functional requirement and second one is the non-functional requirement. The functional requirement decides what the user should be able to do with our application, and non-functional requirements satisfy how the system should behave, basically the specification of the application. The next one is entity defining and API design. In this, we will define different tables that are going to reside inside the database, and in API design, we will define different HTTP REST endpoints, what are the body or payload that they are going to contain, and what response each request expect. We'll discuss about that one. Next, this high level design is the heart of this discussion. Here we will try to come up with the diagram and different components of our high level design. And the last one is the deep dive, in which again we'll try to satisfy the different requirements. So the arrows basically define in the high level design. First, we'll try to satisfy all the functional requirements that we have defined in the requirement section. And during the deep dive, we'll try to satisfy all the non-functional requirement that we have defined here. So this is going to be the plan. So without any further ado, let's get started. We'll just minimize this and keep it here for our reference. So first one will be the requirements phase. First one is functional requirement. We'll try to keep the functional and non-functional requirements to a minimum, so that within 50 or 55 minutes of time we can touch all the avenues and discuss every aspect. It should not be like we listed 5 to 10 functional requirement and non-functional requirement, and by the end of the discussion we hardly complete 3 or 4 requirements. So we'll try to keep it minimum. So the first functional requirement, so as I mentioned earlier, all the functional requirements should answer what the user should be able to do. So user should be able to create, read, update and delete tweets, basically perform CRUD operation on tweet. Second one is, again, they should be able to like, reply or retweet. Third one is user should be able to follow other users. The last one is the important one. User should be able to see tweets from the users they follow. We can also list different things here, but we'll try to keep this as a minimum. Moving on to the non-functional requirement. First one is all the non-functional requirements should answer what the system should be able to do. So our system should be highly available, then consistent. So here I would like to take the discussion towards a different direction, and I'll try to mention something about the CAP theorem. Most of you might have heard about this CAP theorem. In this CAP, there are 3 components. The first one is consistency, the second one is availability, and the third one is partition tolerant. So let me mention about this one. First one is consistency, second one is availability, and the third one is partition tolerance. So what CAP theorem says, that consistency means whatever there in the database, when I try to fetch something, it should show me the exact data that is there in the database. Otherwise, it should not show me the wrong information or not updated information. Availability on a very high level means that whenever I try to access the application, I should be able to see the things as fast as possible, and every time I try to access the application, I try to load the feed or try to see any particular tweet, always I should be able to see the tweets. That means the response should always be there and with some meaningful content. Consistency means either I should see the correct data that is there in the database, or I should not see any data at all. Partition tolerance means in any case my application should always be there, like my application can never be unavailable. So in this gap theorem, this partition tolerant is tolerance we cannot avoid. Like our application should be able to, in case of any fault or any other situation, our application should always be available to the user, right? So in this case, we have to now make a balance between consistency and availability. So these two things, they cannot come together. Either we can achieve consistency or we can achieve availability. So based on that, from our Twitter perspective, so let's say I went to Twitter and try to load my home page. So I should be able to see all the tweets from my followers. For example, your friend just tweeted a new tweet just a minute or a seconds ago. So now that tweet is there in the database, but it generally takes some times to reflect that particular tweet in the followers list. So if we go with high consistency, so when my feed loads, it should always show me that recently posted tweet. Otherwise, if it's not there, then it should not show me any tweet at all. So that is not acceptable in our case. So whenever I try to go to my homepage, I should be able to see tweets. If any particular tweet comes after 5 minutes or 3 minutes, then it's not end of the world. That is acceptable here. So this is all about cap theorem. Moving on to the next non-functional requirement is here the users are going to make a lot of tweets. They are going to fetch a lot of tweets. So here the application should be able to handle high volume reads and writes. I would like to mention here the number of reads will be much higher than writes. It is obvious, right? We don't always tweet, but we always refresh our homepage or feed or try to look up the tweets made by other persons. And whenever I am going to my home page, the feed should load very quickly. So it should have a low latency for the feeds, I would mention. And it's better to quantify any value where if you say like low latency, then in that case, it's better to mention some value. So 250 milliseconds or 300 milliseconds is the basically what you can say real time with respect to human perseverance. So we can say 200 milliseconds is fine, and we should be able to, the application should be scalable, and we should be able to handle 100 million plus daily active users. So here I would like to mention that do not spend much time in this requirement gathering phase. So just list out the functional and non-functional requirement and cross-reference it with the interviewer whether he likes to add something to this list. If not, then move on. So moving on to the next phase. Here we'll like to define the entity. So the first entity will be, of course, users. The second entity will be the actual tweet, and the third entity will be follow. I'll mention why I'm creating different entity for follow, and the last one will be reply. So this is basically covers all the requirements that we are going to discuss in this discussion. And one thing, we are not going to define the different attributes of this tables, like what the content will be there for users, the user ID, name, and everything. We'll define everything during the high level design phase, because in advance I can't know what are the different fields that are require and how the different tables will be linked with each other. So that's why the next phase is defining API contract. So the first one will be post request. So in API, defining the API contract, what we can do is we can look at the functional requirement, and based on this functional requirement we can define the different endpoints here. So the first one is user should be able to create tweets. So we will go with a post post request, the endpoint will be like API tweet, and the request body, this will contain the actual tweet. It's indented. The next one is, of course, get endpoint. This we can make it for to get a particular tweet, and we can provide the tweet ID here, and this tweet in the get response will get, of course, tweet will be returned. Next is post request. Again, user should be able to follow the other user. So next one will be API/follow, and we can provide the body like the followee ID. Again, it will be a string. And last but not the least, a get request to get all the tweets from the users that the user follows. So the returned thing will be an array of a list of tweets. So this basically completes our two different steps as we have discussed earlier, the requirement defining phase and the API design phase. So now we'll move on to the most important aspect of this video, the high level design. Let me do a resize here so that we'll get enough space to do this one. Okay, let's move this thing a bit side here. Okay, so in this high level design, we'll try to follow the API contract. Like the first one is to create the tweet. So going back to this functional requirement, user should be able to create the tweet. So here first we'll can draw the user itself. So we'll name it as a client. So we'll name it as a client, be it a mobile device or a web application, that doesn't matter. So from this device, user will make the request. Next one is a API gateway. So we will have different services based on our requirement. So the client won't have access to different services directly. All the services will be exposed through a common interface, that is API gateway. So client will be making request, and based on which service it needs to communicate with, that will be decided by this API gateway, and then the request will be forwarded to that particular service. So API gateway, it may perform different operations like authentication of the user, then basic rate limit, then distributing the traffic to different services. And next comes the actual service. We can name this as a tweet CRUD service. So this will contain all the logic to create a tweet, read and update, delete tweet, everything. And let's create some pathways. So client will make request to the API gateway, whatever is done on the right side, and again after performing operation, API gateway will respond back to the client. So it's a two-way arrow. Then from the API gateway, we will make request to the tweet CRUD service, and after doing some operation, we need some sort of storage here to store the actual tweet. So this tweet, so here there are two options. We can go with either SQL database or NoSQL database. So let's have a discussion on what will be the suitable database for our purpose. So SQL database are better, in which we have multiple tables, and all those tables should have a relation like one to one or one to many. And when we are making operation and creating a response for the client, we should be able to perform joins operation on different tables. That way SQL database helps us. But in our case, this particular table, it will contain only the tweet, this entity that we have defined, the tweet entity. So this database will contain only this tweet entity. So here we won't need any complex query or complex joins here. Again, in our non-functional requirement, as we have mentioned, there will be a high volume of reads and write. So to handle high throughput of reads and writes, the NoSQL database or the document style database are very efficient in that way. So in this case, we will go with the NoSQL database, and for our discussion sake, we'll go with MongoDB. So this will be our tweet database, right? So this will make request to send all the information regarding the tweet, and that will be stored in the tweet database. So now this is a good time to define what will be the content of the tweet. So obviously it will have an ID, user ID, the actual content. So we can say text. What is the text? Again, the likes and the kind number of retweets it has. Again, any media, any pictures or videos that is there that we can store. So here, while creating a tweet, we can have images or videos that involves in that tweet. So any kind of database, be it a document database or a SQL database, is not a right place to store this kind of information like the media information. So in this case, we should be using blob storage, or in this case, we are going with S3 database. So here, while processing, we will send all the media files to the S3 database, and whatever the URL that will be returned, we will store in the media S3 URL, right? So this basically completes our first requirement. So in the API contract, as we have mentioned, the first one is a post request that will contain a text body. So the client will be making a request to the API gateway based on the content of this request. This will be forwarded to the tweet CRUD service. It will perform all the operations, store the media in the S3 storage, and all the different information will be stored inside this MongoDB database. For the next endpoint also, the get tweet, same path we will follow and get the information from the database. We can provide some indexing based on the tweet ID, so that we'll able to find the tweets faster. For reading a particular, let's say here I would like to mention another scenario. Let's say there is a tweet from a very famous personality, let's say Lady Gaga. She created a tweet, and people are trying to get that particular tweet very often. So in this case, this recent tweet will be accessed by various kinds of lots of different users. So in this case, what we can do, we can create in-memory cache like Redis or Memcache, and there we will store the more frequently stored tweet information based on IT, and we can apply a in cache invalid technique, let's say time to live or a list frequently used. So which tweets are gradually they are least used or least request by the user, those will be removed, so that making a ample amount of storage here for frequently used tweets. So this completes our basic CRUD operations here. Moving on to the next functional requirement, the like and retweet. This will be handled by this tweet CRUD service. In the update section, the likes will be updated in this tweet itself. The reply is a different story. Let me explain you this. So for example, Lady Gaga created a recent tweet, and that tweet gone viral, and people started replying to this, and that particular tweet has hundreds or thousands of replies, and nested replies are there. So if we start storing all those replies and replies to those replies inside this tweet document itself, entity will be bloated, and gradually this size of this tweet will be more, and while making queries to get the tweet information, this will be a very large entity to fetch it and again send it to the client. For example, let's say you scroll on the feed of your Twitter. The first thing that you see is the actual content, who posted it, what is the if there is any picture or videos that we see first, then we see the likes, retweets, that thing, any message or text is there, that is. And very few numbers of reply. All the replies are not getting loaded at the same time, because bloating this entity with replies will slow down the get queries here. So to address that one, we'll create a different service here that will be a reply service. And to again, this reply service needs a separate database. So we'll create again this particular database also, a reply db. Again, it will be a document database only. So this will contain the replies of to a particular tweet. It will contain a tweet id, and we can index it by tweet id so that we can fetch the information quickly. So here we will draw the connection between tweet id, tweet CRUD service, and reply service. So let's say I information, or I requested for a tweet, and while sending the tweet to the client, this service will fetch few of the recent replies, and it will add to that tweet and send it to the client, so that the first so the information, so the post will be loaded first and with the few replies, and as you scroll down or click to load more replies will be loaded progressively. So this is we have created to handle viral tweets and all. Moving on to the next service, we'll define a profile service here. This profile service will deal with the user metadata, the username, the profile picture, and everything. So this will be handled by this one. And here we will not be doing the authentication and everything, because that requires a completely different set of functionalities. So what we'll do is this authentication we will delegate to a different service, and maybe if your organization grows up, you can use this same authentication mechanism for other services also. That is how actual practice is for in different organizations, right? So let's say user creates a profile. So for this one, we need to create a database. So this will be a SQL database because here the user profile will be there, and some user will follow another user. So we need to draw different one-to-one, one-to-many relationship between the users. So let's define the user entity itself here. So it will have a ID, and then some name, then a profile picture, then some bio, then some description like follow a list, something like that. So yeah, we can do this one. So here I would like to mention another drawback here. So if we try to mention or try to list the follow list in this entity itself, so gradually this the size of this entity will become bigger, and the relationship between different users will grow complex. So let's say I want to see all the tweets of my different followers. So I will make a request. This will come to CRUD service. CRUD service will make a request to profile service to get all the follower list, and then it will go and try to fetch the tweets of different followers. So to get all the different followers, if there is a user who has millions of followers, or let's say 100,000 or 200,000 followers, to do a complex query of that scale, it will be a bit overhead, performance overhead for this one. So what we'll do, we'll remove this follow list from here, and we'll go with a different kind of database. So this will be a where is it? So this will be a graph database. What it does is, you must be familiar with the tree data structure, that one person is following other person. So it will be the branches of different tree, and that person is following other two persons. So it will be like a tree-like structure. And based on that, this is very fast in getting that kind of information particularly. So we can take help from the graph database, and again this will act as a social graph, right? This graph db is particularly helpful in creating the social graph. If something is popular among your followers, so that particular thing will be recommended to you as well. So this is where this graph DB comes in. Now we are left with one important endpoint, that is the feed. So this will be, we can say, a feed service or a search service, something like that. Here we will name it as a, so the next service is search service based on different parameters like name, date. You can send in the request the date range, the name of the follower, or in the search bar you can search on different, in the search bar you can search on different topics and everything. So this is the work of the search service. So let's say you make a request to this search service. So what it will do, it will take the request and go to the feed. Here, based on the search term, it will try to based on the search term, it will try to fetch the different tweets that contains that particular search term from the database, and it will return the response. But there is a limitation. Like, let's say I search for large language model, LLM. So there might be thousands of tweets that mention this thing. To get all of them at once and reply to the user, this is practically not possible. So in this case, what we can do is we can take help from a different kind of database. That is, we can take help of Elasticsearch. So Elasticsearch is particularly helpful for a large database in which you require different parameters to search upon. So Elasticsearch is full text search database which stores all the information like the tweet content, username, hashtag based on that, and it stores it in a reverse index manner so that it will be easier for it to provide you with the result. So let's say in place of large language model, you misspelled it large language modem. But again, in that case also, Elasticsearch is very efficient in returning you with the actual response. So how this Elasticsearch work is, there is a concept called CDC, like change data capture. So whenever any new tweets are posted or in the MongoDB database, so all those information will be captured and processed in the tweet data, and that data will be latest information will be shared with the Elasticsearch, and based on that it will do the re-indexing so that all the latest information are in sync with this one. So with this we have covered all the functional requirement of our application here. Now we'll start with the non-functional requirement. So the first non-functional requirement is the application should be highly available rather than consistent. It means this thing is mentioned regarding to the read performance. So a client or a user try to read any tweet, so that person should be able to see the tweets as soon as possible, and every time we should be able to get the response from the database. So here we can create multiple instances of this tweet CRUD service, which will be able to handle all the different traffics and all. And MongoDB database, we can scale it horizontally, so scaling is not a issue with the this kind of database. In production environment, definitely you will use some serverless database like a DynamoDB. So for the AWS DynamoDB, there is no limitation, practically there is no limitation to which it can be scaled up. So storage for this document data is not an issue. And as far as the service processing is there, we have defined that this is already taken care of. So we have satisfied the function, the first non-functional requirement, that is the system should be highly available. Along with it, here what else we can do is we can create some CDN network near the geographical area. Let's say the client who is accessing this information is there in India, and the actual server of the database that is there, it lies in US. So there is a physical distance that needs to be factored in for the quick response. So what we can do, we can create a network of CDNs that will fetch the latest information from the MongoDB, and the user will be able to fetch the tweet information directly from the CDN. So thus by reducing latency. So here, this is how we can address, low latency also. Then again, the high volume of read and write that we have already discussed, the multiple replica of the service, and the document database, which is very efficient in a high throughput operation like reads and writes. So that is already covered up. The next one is the low latency feed. So this is our different topics, and I would like to go deep into this, how actually Twitter does it, and it will take a few moments to discuss it. Okay, so how Twitter does it is, there is a concept that is defined by Twitter like fan out. So now we are going to discuss about the feed of the different user. So let's say any user opens up the application and goes to the home page. So that person should be able to see all the tweets from the different users that they follow, and those should be in a reverse chronology, like the latest information should be shown first, and gradually the older tweets should show there. So this particular information is completely different from user to user. So for every user, this feed, the list of tweets that is there in their homepage, it is different for all the user. So let's say the Twitter is dealing with 100 million daily active user. It is practically not possible every time the user is trying to access the feed that all this tweet from different users can be aggregated and served to that user every time the user try to access it. So Twitter has come up with a different solution that is called a fan out. So I'll discuss about it. So what Twitter does, it pre-computes all the timeline of different user, that is list of tweeters of their followers, and stores it in a different distributed Redis clusters. So there are multiple clusters, around like so many clusters like this, and every cluster stores information about a particular user's timeline. Any request comes in, so based on the ID, the request is forwarded to that particular cluster. As it is already computed, so that timeline is returned to that user. Now this thing is covered that user should be able to see the feed as soon as it reaches to the home page. This is done. Now the real issue comes now, that let's say any particular user created a new tweet. So this tweet is stored in the MongoDB database, and this tweet should be reflected in the followers feed. So how this happens is, once this tweet is created, from this MongoDB, this tweet will be sent out to all the Redis clusters, and the timeline of their followers will be updated. So that's why this is called a fan out. So this is about the fan out architecture that Twitter follows. Right now, again, we'll take an example of a user which has very large follower, let's say Lady Gaga. Now, this particular user has not 100 or 1000, they have millions of users. And after creating any tweet, that tweet will be fan out to all the different Redis clusters, and let's say it starts updating the followers timeline one by one. So what will happen in the worst case, definitely to distribute or update all the feed list of different millions of users, it will take some time. So let's take an example. This particular cluster, all the followers that are there in this cluster, the tweet from Lady Gaga is visible, and that person already send a reply to that tweet. By the time that new tweet is available to this cluster, that this guy is already tweeted, and now this tweet should show, this reply to this tweet should show here. So there is a bit of inconsistency, that this user is getting reply, updated reply to a particular tweet that is not already, there is already a reply for a tweet that is not in this timeline. So it's a bit of contrary. So for who has millions of followers, this fan out architecture is not followed. So in this case, what they do, whenever follower they request for this user's information or this particular profile's updated tweets, then only these tweets are fed into the timeline of this different user. So this is actually how solves this issue of the timeline or homepage creation of different. So this was a very detailed discussion on the high level design of Twitter. I hope we have covered all the different functional and non-functional requirement, and we discussed all the limitation and how we can overcome the limitation by introducing different techniques here. We also discussed about fan out architecture, how Twitter handles creation of pre how Twitter manages the feeds of different user by pre-calculating the feed using fan out technology. So this is it for this video. I hope you like this video. Thank you so much for watching.